Does foliar feeding actually feed a plant? Let's find out. Debbie Flower is here, America's favorite retired college horticultural professor. And we've had guests on the program who have touted foliar feeding, basically putting a water-soluble fertilizer into a can and basically dribbling it over the leaves. Well, one nice thing I can see about that, you're cleaning the leaves. That's a good thing. But can leaves of plants absorb nutrients?
There's evidence they can. First of all, we don't feed plants. We fertilize them. Plants feed themselves. They take the nutrients and make the food. Most of the nutrients are absorbed through the roots. So the macronutrients, including the 3 listed on a fertilizer bag, nitrogen, phosphorus, and potassium, are needed in large amounts by the plant. The micronutrients in small amounts. So you have to get the right stuff to the plant. And then it takes it from there. The conventional thought of foliar feeding is that the breathing pores in the leaves, or sometimes other green parts of the plant, are where plants are able to absorb the nutrients. There were problems with this theory. Those breathing pores are called stoma, or stomata is a plural of stoma. There are problems with the theory. One is most of those on terrestrial plants, ones that grow in soil, are on the back of the leaf. And foliar feeding is typically done to the top or front of the leaf. Another is that when nutrient levels in the leaf were measured, they saw them rising at night. Stoma are closed at night. They open only when there's light, there's enough water in the plant, and there are temperatures sufficient for good plant growth. At night, there's no light, so the absorption couldn't be happening at night. Newer research has shown that these nutrients may be entering very tiny pores in the cuticle. The cuticle is a waxy coating. It's not alive. It's not a cell. It's dead. It's a waxy coating on the plant. Typically, it's on the leaves, and it's there to shed water because diseases, fungus and bacteria in particular, become active when there is a droplet of water available for them to germinate in. And it needs about 6 to 8 hours of that droplet of water sitting there for that fungus or bacteria to germinate. So if the plant can shed water in before that germination time is up, then it can prevent itself from getting diseases. Different plants have different thicknesses of their cuticle. Some are shinier, some are less shiny, etc. But they all have some, not on so much on their very new growth, but once a leaf has matured. So these tiny pores in the cuticle have been discovered. They are incredibly small.
They're real small.
Yeah. Each is less than 1 nanometer in diameter. A sheet of paper is 100,000 nanometers thick. So that gives you an idea of how small they are. There's a problem there with the size of the molecules of nutrients that plants absorb. Plants absorb nutrients only in the ionic form, meaning it has a charge. It's a charged particle, plus or minus. And some of the nutrients come in as complex molecules. They are ionic. They have the plus or minus charge, but they are big molecules. They just physically will not fit through that tiny hole. So not everything can get in. But some things are believed to get in. And, through testing done in laboratories, scientists have watched what happens once those nutrients get into the plant. And in most cases, they stay right where they entered. They don't go to the roots. They don't go to the stem. They don't leave and go to another leaf. They just sit right in that leaf. The conclusion about foliar feeding is that it's not a good way to get all the nutrients that a plant needs to the plant. That should be done at the soil. There are a few instances where foliar feeding is very beneficial, and that one in particular is when the leaves are iron deficient. Iron is a nutrient that the plant needs in very small amounts. When the plant can't get enough iron, the new growth, the leaves will have green veins and be yellow in between the veins. A solution for that is to foliar feed with iron. And there's specific iron products made for foliar feeding.
Water-soluble products?
Yes.
Okay.
They're typically chelated, iron chelates. They're encapsulated so that they can be dissolved into water. There's plus and minus charges with water and iron, and that make it more difficult for iron to dissolve in water. the iron molecules themselves are manipulated. But they still have to be very small, which is a problem. So foliar feeding has its uses for very specific, typically micronutrient deficiencies. Some macronutrients might get in, but certainly not in the quantity the plant needs. So the practical use of foliar feeding is to correct a deficiency of a nutrient in the leaf.
So if that citrus tree has chlorosis, which is an iron deficiency, foliar feeding might cure that leaf.
Exactly. It doesn't solve the problem.
Yeah.
It cures that leaf. And zinc is it copper? Are the other two micronutrients that citrus sometimes lack, and you get a very similar looking appearance. And both of those, I believe, can be foliar fed as well. You have to buy the specific product, but you're right. It solves the problem in that leaf alone. It does not change the conditions in the soil that are preventing the plant from getting that. So it's a very temporary ornamental solution.
As we are fond of saying on this show, you're not feeding the plants, you're feeding the soil, which in return feeds the plants.
Absolutely. Absolutely.
So keep feeding the soil.
Yes.
All right, Debbie, thank you.
You're welcome.